Hello, this is the practice exam, question 3, and we'll go through parts B, C, and D. And in each of these ones, they want to know the heat, work, delta U, and delta H for each of the steps. So going A to B, part B, B to C is part C, and then overall for part D. So, not part A, sorry, part B of question 3 then. We know that this type of process is a constant pressure process. So that means our heat that we're trying to find is heat at constant pressure. And heat at constant pressure is equal to our enthalpy change. Remember, we derived this in class, so look back through your notes if you'd like. There's our delta H, and our equation for that is mCp delta T, all the time for expansion or compression of an ideal gas. So if you do pop in our numbers, so in part A, you calculated out, you figured out all the different temperatures. Cp and Cv are given to you in part A or at the beginning of the question, and you know you have 1 mole of gas. So you should end up with a value here of minus 6,937 joules. Now we can go ahead and solve for delta U, which is NCV delta T, all the time, doesn't have to be a constant volume process. And we derive that as well within the notes. This case here is minus 4,954 joules. So we have heat, enthalpy, delta U. We need to find work, which is going to be equal to delta U minus Q. So you should end up with a value of 1983 joules. Work was done on the system in order to compress it. Now part C, there are all your ones there. Part C, we're heating it at constant volume. So right away, if delta V equals 0, then our work is also 0. That one's taken out of the equation right away. Our heat is a constant volume, and constant volume heat is also equal to delta U, which is NCV delta T. And the value in this case is 4,954 joules. Delta H, our equation for that is NCP delta T. And in this case here gives us 6,937 joules. Done that one. Now part D wants the overall. So going from A to C. Look closely at that. In that case there, it's overall, our temperature is not changing. So that means that our delta U and our delta H are also both 0. Because in those equations, remember, we have a delta T function. So if that's 0, the rest of it is 0. And for our work and heat, you're just going to add them up. So our overall work, you're just adding up one with the other. You're going to have 1,983 joules. And for heat, doing the same thing, you're going to have minus 1,983 joules. So hopefully it does work out that way, because if your delta U is 0, that means that Q has to equal W in that case. So there you have it.